Hi everybody, my name is Sean O'Kane with ChipEstimate TV and ChipEstimate.com, where we bring you the latest information on semiconductor design and IP. My guest today is Jim Hogan, a sage soothsayer and consultant to the stars. Thanks for joining us today.
You're welcome, Sean.
All right. You being a investor in EDA and IP, you typically see trends quicker than most folks. What can you tell us a little bit about the IP trends going forward in 2013, and then we're going to go into some of the technology that has been released here and talked about.
Well, I think IP, and specifically patents, are increasingly something that's used and valued in the company. Look, the MIPS deal that just went down, MIPS sold its IP portfolio to consortia for, I think, $349 million. And they turned around and had this bid between Imagination and CEVA for the operating unit, and that yielded $100 million. So think about that, it's $449 million for the enterprise. Of that, 3/4 of it was the patents themselves. So, and if you look at the Google patents that were done, Apple's need to get more patents. The world is becoming more and more aware of intellectual property. I think when we talk intellectual property in this audience, we're often talking about design properties.
Yeah. And there's a number of IP companies that are represented here at the Common Platform Tech Forum 2013. But that's interesting, and it's a good point. The design IP does factor in to a lot of this, a lot of what you're talking about. And this patent technology, but a lot of these are smaller IP companies. And I know you can talk a little bit about that. Let me jump a little higher, and then we can come back. So a lot of the discussion today at the Common Platform Forum today has been this 14 nanometer SOI FinFET technology. This is the FinFET is that three-dimensional technology that along with the collaboration with IBM, Cadence, and ARM. How important is that, and what does that mean?
Well, if you look at transistors in 2D, they're starting about 40 nanometer. The dominance of transistor leakage, or the leakage current, became increasingly more difficult for a device to operate at performance levels that were theoretically capable of that process. So it added a lot of variance to the process, and therefore it tightened up the distribution for the SPICE models, for example. So that left a lot of performance on the table. So by going to 3D, it really helps the leakage. And that makes it more predictable. It doesn't hurt density. However, on the EDA side, it creates all kinds of challenges, because now you have another dimension to consider, and it's going to probably require a lot of the EDA tools, for example, to be rewritten, like SPICE engines and things like that, to deal with the 3 dimensions. It also has the impact of dealing with characterization. Characterization will become increasingly more dominant as a business opportunity for EDA companies, and something that the physical library guys will have to deal with increasingly in terms of scope. Therefore, libraries, I'm afraid, will be getting a lot more expensive in the near term.
Yeah, but the low power initiatives and factors, you know, have you heard of silos?
Yeah, sure.
Now, with the collaboration with ARM and GLOBALFOUNDRIES, they've wrapped this company in, specific to their low power techniques, and I find that very interesting. And then we're making our way back to these smaller companies.
Well, my view is that power is something that's realized at the device level for a phone or a server, for example. And there's a couple things you can do. One is you can do what Apple does and sort of sequence the applications in a specific way to ensure power is only used when you need it. Then there's sort of the SoC guys that try to optimize power across an SoC in terms of scheduling and stuff, and there's a bunch of companies that do that here. Then, if you drive down even further, kind of stuff you're talking about, is down at the physical level, especially with regards to a foundry opportunity, that there's some degrees of freedom, and you got to converge on the most optimal set. So that will happen over time. These are things that require learning. It also has the opportunity, from my point of view, be pretty disruptive and require people to consider different methodologies. So that means new tools, new IP. So that's good for me.
What a perfect way to end this conversation.
Oh, thanks.
Anyway, thank you very much.
You're welcome,
Jim Hogan.
You're welcome.
For Jim, my name is Sean O'Kane with Chip Estimate TV. We'll see you next time.